Hi everyone and welcome to this video. In this video we will be learning about present value annuities. Okay, so what is a present value annuity? A present value annuity, which I will just abbreviate with PVA, is a regular series of payments of fixed amount, and I could actually say repayments, a regular series of fixed amount repayments for a certain number of time periods for the purpose of repaying a sum of money received at present time. Okay, so it's a regular series of fixed amount repayments for a certain number of time periods for the purpose of repaying a sum of money received at present time. So like a loan. This is best understood with a timeline. So I'm going to draw a timeline over here. Let me rather do it like this. Okay, and then this is of course T naught, which is present time. Okay, and one period after T naught we'll have T1, that's one time period. Whatever the time period is, it could be a month, it could be a year, it depends on the context of your situation or the question you're answering. Then we have T2 all the way. This would be Tn, one time period before Tn we have Tn minus 1, and of course Tn minus 2, and we have all these time periods in between. So let's say at time 0 a sum of money is received, and let's call that value P. So a sum P is received at time naught. Okay, so at every next time period a fixed amount is paid back. So let's say at x1 x is paid back towards repaying the value of P. At T2 another x value is paid, at T3 another x value is paid, and so on all the way up until Tn. Okay, so each of these regular payments of x need to be decayed or discounted back to time 0. So like this value needs to be taken back to time 0. So in this case it will be x times 1 plus I, whatever the interest rate is, to the power of minus 1, because it's being decayed or discounted back just one period. This payment of x repayment, which is made at times 2 towards repaying P, will be decayed or discounted back 2 periods. So it's 1 plus I to the minus 2, and so on. So this one will be 1 plus I to the minus 3. This one will be x 1 plus I. This one was made at time Tn minus 2. So this will be minus n minus 2, right? And so on. This will be x 1 plus I, n minus 1, and this last one, which is the final repayment. So after this repayment made at time Tn, the total amount P will have been repaid, but this value of x, that payment, is to be discounted back all the way in time periods. Okay, so what we have is that the sum of all of this, right, all added together has to equal P, so that the amount received at time t0 is repaid. Okay, so I'm gonna write out the sum like this. We're gonna have P is equal to all these terms over here. So the first one is x 1 plus I to the minus 1 plus x 1 plus I to minus 2, and so on, all the way to x 1 plus I to the minus n. Okay, so what do we notice about this series? It's a series because it's a sum of a certain number of terms, but it's not just any series, it is a geometric series. Why? Because it has a common ratio. Okay, so what is that common ratio? To find the common ratio, all we need to do is take any two consecutive terms. I'll take the first two, and we divide the second one by the first one. Right? So x 1 plus I minus 2 over x 1 plus I to the minus 1, that's going to give me 1 plus I over minus 1. Okay, these x's cancel out, and I'm left with 1 plus I to the minus 1. So that is my common ratio, R. Okay, so something I know about geometric series is we know there's a nice formula for the sum to n terms. I'm going to remind us what that formula is. Okay, so we denote by the sum to n terms as Sn. The sum is equal to A multiplied by R to the power n minus 1 over R minus 1. So where R is the common ratio and A is the first term and n is the number of terms. Okay, so if we substitute the relevant values into this formula for this series over here, we're going to get what? We get P is equal to, well, the first term x 1 plus I to the minus 1, open bracket, R, which is 1 plus I to the minus 1, multi to the power of n. So it's this whole thing to the power of n, which is the number of terms. If you count this number of terms in this whole thing, you get n. And then minus 1, close bracket. Now R minus 1, so it's R, which is 1 plus I to the minus 1, minus 1. Okay, so we've substituted these values from here. Okay, this value, this formula, it doesn't look very neat. So what I'm going to do is I'm just going to simplify it a bit so that it's easier to work with. Okay, P is equal to, so this part here I'm going to write as x over 1 plus I. Okay, and then I've got this big bracket, and in this part here I'm going to write this as 1 plus I to the power of minus n. So making these two exponents into 1. Okay, then I've got minus 1, close big bracket, over, and I've still got these terms in the denominator, so it's 1 plus I minus 1 minus 1 in a bracket. Okay, let's simplify this a bit further. So I'm going to go x, big bracket on top, leave it as easier, and then I've got 1 plus I multiplied by 1 plus I to the minus 1. So I'm multiplying it into this bracket here, and then minus 1 plus I. Okay, so that's going to simplify to, going to leave the numerator as is. Okay, then this multiplied by that just equals 1, right, minus 1 plus I. Okay, so that denominator can be simplified even more, right? So I've got 1 plus I to the power minus n at the top. This is going to simplify to, well, 1 minus 1 is going to cancel, and then it's going to be left with minus I. Okay, so that looks a lot nicer, but I just don't like the look of this minus here, so I want that to be a positive term in the denominator. So I'm going to switch the terms on top, right, and like this. So basically putting a negative sign in front of the whole thing. Or really what I'm doing is I'm going to multiply by minus 1 over minus 1, right? That's what I'm doing. So then minus I times minus 1 just becomes I at the bottom. Okay, so here we have got now a nice formula for the present value annuity. So P, I remind us, if we go back to the timeline over here, P is the value that was received at T naught. Okay, so often in the context of a problem, you will know what this is, and this wouldn't be what you need to solve. But if you, for example, want to know, okay, if I loan out 100,000 and I want to pay it back over 10 years, how much money do I need to pay back per month? So then what you would want to solve is for X. Okay, and obviously this formula is exactly what you would use. Before I end of this video, there's just one thing that I wanted to bring to your attention. Sometimes if a repayment is also made back right at time 0. So this won't, there aren't many contexts in which this happens, but let's say we have another X here which is repaid at time 0. Then the only difference that would be is here we'd have a P, we'd have an extra term here in the front, so that would be X plus etc. And draw this in a different color rather, so we don't get confused. So this is if a prepayment is made at times X, and then simply what we would do is, so if there is a repayment at T0, then we simply subtract X from that initial repayment, from that initial loan value. Okay, so then P minus X becomes the new P, and everything else stays exactly the same. If we think about it, that makes sense, because if I'm going to loan you 100,000 and you immediately pay back in that same moment, you pay back 10,000, it's the same as if I'm just loaning you out P minus X, which would just be 90,000, and everything proceeds as we know it. Okay, but the takeaway from this video is this formula. How did we derive it? Do you understand the timeline? If you do, you'll be just fine tackling any problem to do with present value annuities. And that brings me to the end of this video.